Welcome to This Explainer. Today, we're diving headfirst into the absolutely thrilling history of human calculation. We're going to trace the complete timeline of computers, looking at the exact pivotal milestones that literally transformed how we process the world around us. Let's get right into it. Think for a second about the sheer, mind-boggling scale of the power you interact with every single day without a second thought. Right now, you are holding a device that entirely dwarfs the entire combined computational power of the entire human race from just a few decades ago. It's crazy to think about, right? So, the big question we need to answer in this explainer is, how exactly did we pull that off? How did we jump from primitive counting tools to machines that can write poetry, beat chess grandmasters, and honestly, maybe even think? Let's figure it out. Starting off with Section 1, gears, steam, and punch cards. You see, every early civilization faced one fundamental bottleneck. Numbers are just hard, and humans, as clever as we are, needed some mechanical help to figure things out. To solve this, humanity spent literally millennia inventing tools. We started with bead racks like the Mesopotamian abacus around 3000 BC, moving to a crazy 37-gear analog bronze computer from ancient Greece known as the Antikythera mechanism. Then, we worked our way up through John Napier's calculating rods in the 1600s, right up to a 19-year-old Blaise Pascal, who actually built the first mechanical adding machine just to help his dad count taxes. But it was the 1800s that truly set the stage. Charles Babbage dreamed up this massive, steam-powered, general-purpose computer. It even featured a memory store and a processor mill. Alongside him, Ada Lovelace acted as the world's very first programmer, a whole century before the technology fully existed. She was writing algorithms for a machine that wasn't even built yet. Fast forward to 1890, and Herman Hollerith used punch cards to speedrun the U.S. Census, eventually founding a little company you might have heard of, IBM. That brings us to Section 2, War and Vacuum Tubes. The immense pressures of World War II turned mathematical theory into a matter of absolute life and death. The digital revolution basically just needed one thing to spark: electricity. In 1936, Alan Turing conceptualized the theoretical foundation for every computer ever built, and when the war broke out, he took that brilliant mind to Bletchley Park, helping create the electromechanical bomb device to crack the unbreakable Nazi Enigma cipher. Historians actually estimate this shortened the war by years, saving millions of lives. Now check out this absurd exponential progress. By 1945, engineers had built the ENIAC. This thing was a 27-ton, room-sized beast that sucked up as much power as a small town just to do 5,000 additions a second. Comparing that behemoth to the battery-powered phone in your pocket doing 5 trillion additions a second, it is just a jaw-dropping testament to human engineering. Around that exact same time in 1945, mathematician John von Neumann defined the stored program concept. He proposed that a computer could store its own instructions right inside its memory and dynamically change them. And get this, that blueprint, it's the exact same architecture your laptop, your phone, and your smartwatch are still using today. Moving right along to Section 3, transistors and the silicon chip. So vacuum tubes were powerful, sure, but they were the size of your fist, got incredibly hot, and were horribly fragile. We desperately needed something better. Enter the tiny, cool transistor, invented at Bell Labs, which actually won a Nobel Prize, by the way. This paved the way for massive, refrigerator-sized IBM mainframes. Those same mainframes were used by NASA, with their trajectories brilliantly verified by unsung human computers, brilliant black women mathematicians like Katherine Johnson, to actually get us to the moon. Then, in 1958, Jack Kilby managed to pack multiple transistors onto a single piece of silicon, giving us the integrated circuit. What's wild is that this simple observation, coined by Gordon Moore in 1965 and known as Moore's Law, held true for over 50 years. It literally defined the modern economy, ensuring computers got exponentially smaller and faster year after year like clockwork. All right, Section 4, the personal computer era. During the 70s and 80s, peak disco and bell-bottoms era, computing finally escaped those massive corporate rooms and entered the dusty home garage. Thanks to the fingernail-sized Intel 4404 microprocessor, we saw a rapid-fire explosion of personal devices. It started with the Altair 8800, basically a box of blinking lights, that inspired a young Bill Gates. Then Steve Wozniak and Steve Jobs dropped the highly usable Apple II. This was quickly followed by affordable IBM PC clones, ultimately culminating in 1984 with the revolutionary Apple Macintosh, which gave us graphical windows, icons, and a mouse to just point and click. A real game changer. Let's look at Section 5, the Internet and the Cloud. If the 80s miraculously brought computers into our living rooms, the next era connected all of those rooms together, completely changing the fabric of society. Thanks to the profound generosity of Tim Berners-Lee giving away the World Wide Web for free, and Linus Torvalds releasing the open-source Linux operating system, we rapidly accelerated through the wildly lucrative dot-com boom. This era launched absolute titans like Amazon and Google, taking us right up to 2007 when Steve Jobs unveiled the iPhone, moving computing definitively out of the office and straight into our pockets. Just think about the sheer scale of that shift for a second. By 2023, there were over 6 billion smartphones on the planet. I want you to really let this sink in. More people today own a pocket supercomputer than have access to clean, running water. It's a staggering reality. Simultaneously, the whole underlying infrastructure shifted into the cloud. Tech giants like Amazon, Microsoft, and Google began renting out computing power from massive, sprawling data centers. So instead of buying hardware, companies just rent it. Today, this invisible cloud powers literally everything you rely on, from your late-night Netflix binges all the way to your company's payroll and your medical records. And that brings us to our final chapter, Section 6, Artificial Intelligence and Beyond. This is where decades of theoretical promises and disappointing AI winters suddenly burst into stunning reality. After long periods of stagnation, deep learning arrived in a major way. In 2012, neural networks trained on GPUs completely shocked researchers by dominating visual recognition tests. And then, by 2016, DeepMind's AlphaGo achieved the impossible, defeating a world champion at Go. Keep in mind, Go is a game so intensely complex, it has more possible board positions than there are atoms in the entire observable universe. Look how incredibly fast this is moving now. When ChatGPT dropped in 2022, it gained an astonishing 100 million users in just 2 months. That makes it the fastest product adoption in all of human history. Literally overnight, machines were writing, reasoning, and coding. Alan Turing's old philosophical question of whether machines could think suddenly became a deeply practical, everyday reality for all of us. To put things into perspective today, a single modern GPU contains over 80 billion transistors. And researchers, well, they're already building quantum computers that leverage the fundamental laws of physics to solve problems in mere seconds, problems that would take classical computers the entire age of the universe to crack. We are stepping firmly into science fiction territory here. We've traveled a really long way, haven't we? From a merchant moving beads on a wooden rack in Mesopotamia to a massive language model generating the very script you're listening to right now. The history of computers is clearly far from over. Honestly, it's just getting interesting. Which leaves us with one provocative question to ponder before we wrap up. What impossible problem will the unbuilt machine of 2050 solve?